Good morning, students. Prushi sir again today with a new topic. I have been discussing last 3 days the EMI questions, electromagnetic induction. But today I am discussing a an interesting question on system of particles. Okay, that is climbing up a ladder. As you see, these are my credentials, and all of you must be knowing by now. Okay, what is the question? This question is there in Irodov, but in a different manner. I have included a few more discussions to that question. The question is, a light inextensible rope passes over a frictionless pulley. This is a frictionless pulley with a fixed frictionless pulley. One end of the rope a heavy block M is attached, capital M. The other end of the rope supports a ladder with a man. Man is at the lowest rung of the ladder. The ladder plus man is supported by the other end of the rope. And the total mass of ladder and man is also capital M only. The mass of the man is small m. The mass of the man is small m. The combined mass of ladder and man is capital M. The heavy block and the man are in the same level initially. Just see this. This heavy block and the man in the same level. Means lowest rung of the ladder and the heavy block, that is same level. Okay. The length of the ladder is L. Now what happens? This man starts climbing up the ladder and until reaching the top of the ladder. I will show in the below diagram. So once the man reaches the top of the ladder, there are three questions I am asking. The rise of center of mass of the system. System means the heavy block as well as ladder and the man, as well as the massless rope. Okay. Light means massless. Okay. The second question is the height risen by the heavy block. By the time the man reaches the top of the ladder, how much height the heavy block or heavy mass would have risen. Then the difference of height between the man's position and the heavy block position when the man reaches the top of the ladder. Okay. Difference height between block and the man when the man climbs up the ladder till the top. Now solution. Let us see the diagram below. Same diagram only. For clarity, I have done with two situations. This initial situation. Okay, just copied the other diagram here. And this is the diagram when the man reaches the top of the ladder. When the man reaches the top of the ladder, what will be the rise of center of mass of the system? Initially, center of mass system is C here. C is the center of mass of the system. So when man climbs to the top of the ladder, that C has shifted to some other height. Between C and these two C's, the distance is delta YC. Delta YC means a rise of center of mass of the system. Okay. And this man and the ladder also form a two-body system. The initial center of mass of the man and ladder, this two-body system is C1. Closer to the man when man is at the lowest rung. And when man goes to the topmost rung, then the C1 goes to some other, a bigger height. Okay. So this initial C1 and final C1, the height is delta Y C1. So delta Y C1 means what? The rise of height of center of mass of the man and ladder system. But total center of mass is delta YC. this C and this C. This is the total center of mass. That is heavy mass, ladder, and the man, and the massless rope. So what are the, let's see the terminologies. Delta Y1. What is delta Y1 here? As the man climbs to the top, the heavy block has risen to a height delta Y1. This is the heavy block position, and earlier it was here. So the height rise is delta Y1. Delta Y1 is a rise in heavy mass. Delta Y2, this was the topmost point of the ladder. Now when the man goes up, that topmost ladder is pulled down by a height delta Y2. Delta Y2 fall in height of the ladder. Okay. Delta YC. That's what I have already told you. Delta YC is the rise of height of the center of mass of the system. Delta YC1. Delta YC1 already told you, the rise in height is the center of mass of the ladder and the man system. Ladder plus man. And the height rise by the man itself is delta YA. Man was here, initial position. Now man is here at topmost, and the ladder has also come down. But the positional difference between the difference in height between two positions of the man, initial and final, is the delta YM only M. Okay, M means man. This point is clear to all of you? Very nice. You might be thinking, why, if it is both sides same mass, if any man goes here, the mass is not changing, why it should go up? Because as man climbs, it will pull some, it will press it down, and this tension which was there earlier, it will spike, just goes up and again come down. The man goes to one step and stops. This tension rises and again comes back to this. So this type of impulsive force will act, and which will raise the capital M, as well as the same impulsive force is acting on this ladder and man system. So that will also raise the center of mass of the ladder and man system upward, and that will raise this, that same impulsive tension will raise the man, this heavy mass also upward. So here you understand that the heavy mass as well as the ladder and mass system both will be rising because of this impulsive force by this tension. Tension same both sides. Yes or no? I am asking a question in common sense. T is same, total gravity force is same. So but impulsive force is due to tension, this T only, and T, this impulsive small impulse due to this tension is same also for both. Initially both of them are at rest. So same impulse acting on the heavy block as well as ladder man system. So the finally, since initial velocity same for man, this heavy block and the ladder and mass, so this displacement to the center of mass of the heavy block as well as center of mass of the ladder man system will be same, because same impulse force acting for the same time, and finally coming to impulse becoming zero when man stops. So the center of mass of the ladder man system as well as center of mass of the point block both will rise by the same distance. This is a simple observation. Yes or no? Because same impulse, same for same time it acting, and final velocity is zero also. So what will happen? Both will go to the same height. Both means what? Both the heavy block as well as center of mass of this ladder and the man system both will rise both the center of mass, heavy block center of mass as well as center of mass of the right hand side, both will go rise the same height because the same impulse is acting, and initially both of them having same velocity, zero velocity. Yes or no? So this is what, since the rope is inextensible, rise of height of heavy mass and the fall of height are also equal. And one more thing you observe, if this goes by 1 centimeter, then this end will come down by 1 centimeter because pull is at rest. So, and the string is inextensible. So, if the heavy block rises by some amount, that's delta y1. I think heavy block rises how much? Delta y1. Then this end will come down by same delta y1, but that's coming down. What I'm giving here, delta y2. So delta y2 magnitude and delta y1 magnitude both should be same. The height rise by heavy block and height come down by the ladder only will be same magnitude. So that's what I wrote. Delta y1 is equal to minus delta y2 vector form. Okay, very nice. Since the tension is same as on the heavy block and the ladder, initially the system is at rest. The impulse on the heavy block and the ladder plus mass. I write ladder plus mass, ladder plus man. Ladder plus man are equal. Let me write this with more clarity. आपको मिल जाएगा. Okay. That's what I just explained just now. The impulse on the heavy mass and the ladder plus man are equal. The rise in height of the heavy mass and the ladder plus man system are equal. That means delta y1 is the rise of height of heavy mass and the ladder plus man center of mass. I write better here. Ladder plus mass center of mass Cm, that is C1, are equal. So rise in heavy mass, that is delta y1, and the rise in center of mass of the ladder plus man system, which is C1. C1 is this. What is C1? That's solely center of mass of the ladder plus man. This is C1. This is C1. Now it is here. This two C1 difference and this M difference, height difference, that is delta y1 and delta yc1, both are equal. That means delta y1 is same as delta yc1, and equation 1, delta y1 is minus delta y2. Delta y2 is what? The top of the ladder coming down by that much height. The ladder body comes down by same magnitude of delta y1. That is delta y2 same as delta y1 in magnitude. Okay. So from equation 1 and 2, the magnitude just equate delta y2 magnitude, delta yc1 magnitude. That ladder, whatever distance the ladder is coming down, the center of mass of man ladder system going up by that much height. That's what we found from the equation 1 and 2 combined. So the fall in height of the ladder and the rise in height of the center of mass of ladder and man, ladder plus man are equal in magnitude. If we now comes the real calculation. You fix a reference frame on the ladder. If you fix a reference frame on the ladder, you may ask me why I am doing that. So if we fix a reference frame to the ladder, the man in that reference frame, how much height man rises, goes up by the time it reaches top of the ladder? That is L only. The man climbs up the height L in this reference frame. Perfect. So in that reference frame, how much work is done by the man in climbing up? mgl. Okay. So this work is done by What forces? The internal muscle forces of the man's body. Okay, this you must be knowing from work energy. So we know that the important point written in the red. We know that the work done by the internal forces does not depend on the choice of reference frame. This is clear to you. The work done by the internal forces of a system of particle is independent of the choice of reference frame. Understood this? Suppose a vehicle is moving. The work done by the engine forces is same irrespective of which reference frame you observe from. You are climbing up a staircase, work done by your muscle forces is same from any reference frame, from ground frame, from any other reference frame. It is same only because internal force work done, the work done by the internal forces of a system of particle. My body is a system of particle. The internal force work done, the muscle force work done will not depend upon which reference frame I am choosing from. Okay, so work done by the man is mgl in the reference frame is to the ladder, then it is same in all other reference frame also including the ground. So there is no change in kinetic energy because man is just climbing up and stopping at the top. So delta W man will be equal to delta PE of the system because delta K is 0. This is from Workman's theorem. Okay. So since center of mass of the total system rises by delta YC, then what is delta P of the system? M plus M minus M, that is ladder. This is small m, man, into G into delta YC. So 2mg delta YC is the rise of potentiality of the system. Work done by the man is equation 4 mgl, muscle forces. So then equation 5 says delta remain, that the mgl is equal to PE, delta P of the system is 2mg delta YC. So small mgl is 2 capital mg delta YC. So delta YC is m by 2m capital in small m. That equation 7, and which is answer to question number 1. This is question number 1 answer. Okay, the rise of center of mass of the system. Answered. This was the question of the Irodov, and we have solved it from this man. In this manner, you can solve in different manner also. This is the easier one. Okay. Then we go to the other questions. From the concept of center of mass, we can write capital M delta Y1. Delta Y1 is the rise of the heavy block. And this is the mass of the ladder and the man, M minus M plus small m plus small m, M minus small m plus small m into delta YC1. This is the rise of center of mass of the ladder and man. So capital M delta Y1 plus M minus M plus small m delta YC1 is equal to total mass into delta YC. This is basics of the concept, from the basic concept of center of mass. So this is M common delta Y1 plus delta YC1, 2M delta YC. So, okay. So, but delta YC1 is what? Delta YC1 is delta Y1, that is mass, this rise of heavy block and rise of center of mass of the ladder and man is same. So delta YC1 I'm writing as delta Y1 here. So M delta Y1 plus delta Y1 is 2M delta YC. So that means delta Y1 is delta YC. Okay. So the rise of center of mass of the heavy block and rise of center of mass of the man and ladder system both are equal. But delta YC This is the rise of center of mass of the heavy block, and this is the rise of center of mass of the system of total system is same. Already I have proven that the rise of center of mass of the heavy block and rise of center of mass of the man and ladder system also equal, which where that is all this I have given. Now I have proven that delta y1 is also delta yc only. Delta yc is the rise of center of mass of the total system. For total system center of mass, already I have found equation 7, m by 2 capital ML. So very nice. I can write delta y1 is ml by 2m j cap. J cap is the y direction, upward direction unit vector. So delta yc1 how much? Same as delta y1, ml by 2m j cap. That means delta y1, delta yc1 and delta yc, all of them are this only. Okay. This I write as a clear. So delta y1, delta yc1 and delta yc, all three are ml by 2m j1 j cap. But as you know, delta y2 is the fall of height of ladder only. So that is same as rise in height of the capital M, that is the heavy block. So how much is delta y2 then? Already written that delta y2 also here. Delta y2 and delta y1, they are same magnitude but opposite directed. This is going up, so this is coming down. So delta y2, fall of height of the mass, that is minus delta y1, that is ml by 2m minus j cap. From equation 1, which is just I showed you. Let the rise of height of the man is delta ym. Actually, I can do that directly also. The ladder has fallen by this much, man has climbed up by L. So total rise of man will be L minus ml by 2m. That I can write, but I am doing it in a different manner. Let the rise in height of the man is be delta ym j cap, which I have written already. This in the beginning itself, delta y rise in height of the man. Okay. Right. So m into delta ym j cap, just from the concept of center of mass. Then I'm talking about the center of mass concept applied to ladder and mass system. So ladder and man system. M delta ym j cap, this is the man and this change in position of the man. This is ladder, m minus n, mass of the ladder. Delta y2 is the fall in the height of ladder, is equal to total mass of the man ladder system, that is m plus capital M minus small m, that is capital M only, into delta y c1. That's it. Already I know this delta y2 is ml by 2m minus j cap, and this is delta y c1 is same as delta y1, that is ml by 2m j cap. This I am writing m delta m j cap, m minus m, ml by 2m minus j cap, m into the ml by 2m j cap. J cap you cancel from both sides. M into delta m is m minus m, ml by 2m plus m ml by 2m, that is are there. So 2 mm minus small m square L by 2m. So divide, cancel small m from both sides. So delta m is 2m minus m by 2m L. Okay. So the position of the man rises by this much. Okay. Then the position of the heavy mass, how much is risen? Already I calculate delta y1, that is ml by 2m. Then what is the difference of height between man and the heavy mass? This minus this. This position of man risen by delta ym, or the height risen by the heavy block by delta y1 or the rise of center of mass is with respect to which? With respect to ground frame. So let me write also, so that in all the delta y terms are with respect to ground reference frame. Okay, am I clear? So finally it has gone up to by a height of the height difference between the man and man's position and the heavy block's position is this man's position with respect to ground, the heavy block's position right, the man's position, man's right with all with respect to ground. So their difference is this much, m minus small m by capital M minus small m by capital M into L. Answer to this is the question number 3 का आंसर. क्वेश्चन नंबर 2 का आंसर है कितना राइज किया सेंटर ऑफ मास दैट हेवी ब्लॉक ऑलरेडी टोल्ड सेंटर ऑफ मास ऑफ द सिस्टम, सेंटर ऑफ मास द लैडर एंड मास सिस्टम and center of mass of the heavy block itself all rise by same amount, already proven. So question number 2 is answered. Question number 3 also important, that is answered. If capital heavy block is 100 kg, mass of the ladder is 50 kg and mass of the man is 50 kg and length is 10 meters, then height of cm is how much? ml by symbol of the system is ml by 2m, 50 by 200, 100, that is 2.5 meter rise. Rise in position of the heavy mass, same ml by 2m, 2.5 meter. Difference heights of the man and the heavy mass, difference heights in man's position and heavy mass position, that is this one, m minus m by capital ml, 100 minus 50 by 100, so 5 meter. That's that. So even if they are at initially same height, now the height difference is 5 meter. Okay, I think all of you understood this. This is very important for all of us. This particular point to understand is this question is very important to for all of you. So I have just added a few things to that question in period of. All of you are clear? Okay, the major point is that work done by the external forces of a system of particle is independent of the choice of reference frame. This point should be very clear to all of you. Okay. Okay, this is an important question. I thought that I should give some time to this. I think all of you understood. Other critical topics I'm going to discuss very soon. Keep a track of my channel. Subscribe it if you have not yet, so that you'll get information when I upload anything. And keep coming to check my videos and give me your feedback, whether you like it or not, if anything else you require, anything more you require, or anything you want to be reduced, just give your suggestion. I'll be happy with that. I'll try to improve on my channel, and you also give your requirements, which topic you want discussion, we'll give. Okay. Okay, best of luck for your upcoming examinations. Have a nice day.